Okay, we are learning, we're doing a mini unit on powers and exponents in the little properties that are aligned with it. 4.7 is the actual lesson we're doing today. It's exponent properties with multiplication. You're learning target. You can simplify powers with exponent properties. You're going to love it. As long as you can identify the pattern, you will love it. But don't read ahead. Let's discover the pattern by itself. Before we discover the pattern by itself, we need to know some properties. Similar bases. Two terms have similar bases if they have the same big number. We're going to say big number. Now I noticed that you guys already hated how I did my image here. It's going to be okay. I'm just going to reflect it. And there you go. Now it's pointing at the exponent, okay? So the base is the big number. The exponent is the little number. Combined, they're called powers. Okay, a power has a base and it has an exponent. All right, we're going to go through and identify which bases are the same. Do this in your notes now. Connect like bases. It is very critical that we can identify like bases because that's the foundation of this lesson. So with lines, just connect the like bases. X cubed, what's the same base as x cubed? X to the fourth. So x cubed goes to x to the fourth. 2 to the fourth. What is the same base, Audrey?
2 to the 7.
2 to the 7. Y squared, what's the same base, Eric?
Y to the 6.
Y to the 6. Negative 5 to the negative 3 is the same base as what, John?
Negative 5 to a 4.
Negative 5 to the 4. A to the 7th is, of course, A to the 8th. Okay? Identifying like bases. Concept 1.
Please do.
All right. Now, let me help you. This is us formulating the property. We are going to formulate the rule. I know these are stapled weird. I pushed the wrong button in the copier. I'm sorry. Just deal with it.
Okay.
It's going to be okay. So, x squared times x cubed. There is a pattern. There is a relationship. Let's see if we can develop it. X squared means there's two x's. X and x. Let me do a different color. X and x. Two x's. Times x cubed, I have three x's. 1, 2, 3. That combined together is x to the 1, 2, 3, 4, 5. X to the 5th. Now think to yourself, how do I get this 5 from the 2 and 3? That should be, you're looking for a pattern. That should be the start, your formula hypotheses. Now let's see if you're right. W cubed times W to the 4th. W cubed means that I have 3 W's. W to the 4th means I have 4 of them. 1, 2, 3, 4. I have a total of W to the 1, 2, 3, 4, 5, 6, 7. W to the 7th. Think about the pattern. Now don't tell me the pattern yet. Think it through. And I want you to test it and see if you're right if I had x to the 4th times x to the 6th. I want you to write this one down in your notes. I want you to write what you think it would be if you're discovering the pattern, what you think it would be, and then I want you to expand it out. Now today you won't have to expand out, but while we're developing these rules, you will. Okay, what do you think it's going to be? X, so just tell me.
10.
And what did you do to the exponents to get to the 10? Just tell me. We thought you add them. Now let's test it. So that's our hypothesis. Like, okay, I think I need to add the exponents. Let me prove it. Let me see if I'm right. So I have 4 x's, and then I have 6 x's. 1, 2, 3, 4, 5, 6. Okay, I did it. I expanded. Now I have x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Hey, it looks right. You look like you just developed the rule for product of powers property. So a product of powers property tells us that if you're multiplying two of the same bases, you just add their exponents, but they have to be the same bases. How you say it, this is fun. A to the n times a to the m is equal to a to the n times n. Okay? Dang it, yeah. Okay. A to the n times a to the m is equal to a to the n plus m. Yes, that means a is the base. A to the n times a to the m is equal to a to the n plus m. It just sounds crazy. A lot of times math just likes to sound super crazy. Because we like to make things seem super difficult, even if they're not.
Why do we do that?
I don't know.
We're weird. Who created humans?
Pythagorean was one of the main founders. Okay, example. 2 cubed times 2 to the 5th. And Euclid was another huge contributor to the foundations of math. So it was Pythagoras, and then Euclid. They were the main discoverers of math. 2 cubed times 2 to the 5th is equal to 2 to the 3 plus 5, which is 2 to the 8th. All right, then we expand it.
Easy. You got it.
Then we expand it to coefficients. The first thing that you do when you're given coefficient examples is just multiply the coefficients. Multiply your coefficients. And then secondly, you'll add exponents. Exponents of like bases. You cannot add exponents if they do not have similar bases. It's like combining like terms. You can't combine x and y. Okay? You just can't. 2x to the 4th times 3x squared would equal, now I'm going to expand it out, 2 times 3x to the 4 plus 2. Now imagine if I made you show your work like that. Luckily you don't have to. I'm just doing it while we're developing into this. This is equal to 6x to the 8th. Just kidding, 6.
Yeah, I'm like, what?
6. So again, you can do this fast in your head. You could go 2 times 3 is 6. X to the 4 plus 2 is 6. 6x to the 6.
Easy.
Okay. Negative 3x to the 4, y to the 5th, times x cubed y to the 4th. Negative 3 times, actually there's a 1 there, right? So negative 3 times 1 is negative 3. X to the 4 plus 3, y to the 5 plus 4. That's the quick way. That's how I would do it. Again, you could go you could expand it. Boy, that would stink. But you could totally expand it. That's a strategy. If you're ever stuck, you can always expand, and then it helps you visualize it. Or you could say negative 3, x to the 4 plus 3, y to the 5 plus 4. Either way, I'm thinking this is the best.
Or you could do mental math in your head.
You gotta write it down. This is mental math. The first one is mental math in your head.
What if you get that wrong?
Then you're wrong. No partial on these things.
Why not?
If there is no exponent, you put a 1. If there's no exponent, you put a 1. So 3x times 5x to the 5th is equal to 3 times 5 is 15. X to the 1 plus 5 is 6. Okay? 3 times 5 is 15. X to the 1 plus 5 is 6.
Wait.
Why don't I ask you if we
Okay. 3ab to the 4th times negative 2a to the 5th b is equal to negative 6 a to the 1 plus 5 b to the 4 plus 1 negative 6 a to the 6th b to the 5th. Final answers. times 2 to the 7th. What do you think that's going to be? Now, a lot of students mess this up. Let me just tell you first that. But that might trigger, I might not get accurate results here. Do you think it's, which one? Which one do you think it is? Think, pair, share, and support your answer. Which one do you think it is and why? Okay, think, pair, share. Talk to somebody next to you. Now this is one that most 8th graders mess up tremendously. They think it's this. That is not the right answer. Because you don't do that. Remember, if you had x squared times x to the 7th would be x to the 2 plus 7. I kept my base. Since I need to add these, I just keep the base. The base is 2. 2 to the 2 plus 7. So when in doubt, substitute a variable in there. It's funny because when I get the numbers in there, kids mess it up way more than a variable. Okay? So you don't do that. You don't multiply them. Elizabeth? Like 2 squared x to the 4th times 2 squared? Like that? Or, and have another x there? I would not, actually let's do that. I would still say, okay, I have a base of 2, so it would be 2 to the 2 plus 2, x to the 4 plus 3. Okay, so it would not be 4 to the 4th. It would be 2 to the 4th, x to the 7th. So be careful for that. Next page. Okay, we're going to formulate another rule. So we learned what? Adding exponents is product of powers. Okay, now I want to say, what does this thing mean? X squared cubed. Now we're going to formulate it. This is saying x squared how many times? Well, x squared is inside it, x squared 3 times. So this says x squared times x squared times x squared, which is x to the 2 plus 2 plus 2, which is x to the 2, 4, 6.
Couldn't you just multiply the 2 with the next one?
Okay, so we're developing you noticed a pattern. Let's test it.
I see.
Okay? I don't want you to test it with this next one because this is a little bit more advanced. Test your hypotheses with this. A to the 4th cubed. A to the 4th cubed. What do you think with your pattern that you saw? What do you think it would look like? Okay, Austin, what do you think?
A to the 12.
A to the 12th. So tell me what you did with your exponents.
I times
Okay, let's test it now. A to the 4th 3 times. Which is a to the, remember addition, multiplication is repeated addition. So that is a to the 4 times 3, which is a to the 12. Beautiful. This next one's a little bit more advanced. This is really a 3, now I'm going to expand this out here, okay? This is really a 3 to the 1st, let's stop. You can apply this rule, but you have to distribute it to everything. It's just like when you distribute to everything inside. Let me show you the expansion part. This is 3x squared times 3x squared times 3x squared times 3x squared. One more time. Okay, similar bases. All of the 3's are to the 1. So this is equal to 3 to the 1 plus 2, 3, 4, 5. 3 to the 5th, x to the 2, 4, 6, 8, 10. Notice I distributed my power to